So in case you missed it, it sounds to me like what we're doing when we're designing an experiment sounds a lot like science class, doesn't it? Yes, it does. Science class in terms of natural sciences like chemistry and physics, and also social sciences like psychology and education. See, you identify what, I'm not going to read all of this to you, by the way, read it on your own, but I'll hit the highlights. So you identify what you want to, what problem you want to solve. You want to know what makes students do better on the SATs. So you determine factors that could affect the response variable. Teaching, study time, sleep time, what they ate that morning, etc. You determine how many experimental units you're going to get, right? And we'll talk about that a little bit more in chapter 9. There are some formulas for that. Determine how many people you got to look at. Then you determine the level of each factor. Are you going to control them? Are you going to make all the students eat the same amount of the breakfast every morning for the week leading up to the SATs? Are you going to make them all sleep that night no matter what? Are you going to make them attend a class or not attend a class? Like a SAT prep class, that kind of thing. And you have to randomize too, because you have to make sure that each of the groups that's in the control has same number, not same, but same proportion of men and women, same proportion of different ethnicities, same proportion of different religions and creeds and etc. And income levels. Income is big with education. And then you actually conduct the experiment. You get all your control groups into place, and you say, okay, you guys are all going to take this class. You group are not going to take this class. You're all going to sleep the same amount, eat the same amount, blah 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 blah. And then you see, do they do better on the test because of this class? And then you have to be able to repeat that. Somebody in Sweden has to be able to do the same experiment you did and do it over and over and over, right? And if they can't, then that probably means you did something wrong, right? And I know I'm skimming over it, but any scientist worth their salt knows that this control thing is where a lot of the work in science comes, because truly being effective in your control can make the difference between your study being effective and not, right? And then when it's all over, you'll test your claim. Hey, did the students do better or not? Let's see. And we'll get into what that shows in chapters 9 through 15. That's where we're heading. So if you show that the average test score is higher for this group, did that prove that your little SAT prep class was effective? Maybe. Maybe not. It depends on how effectively you controlled and how effectively you randomized and how you conducted the experiment. A lot of things can go wrong in these steps in here. Okay, lots. But if you do it right, then everything should be great, and you'll be able to prove that your drug kills cancer. Okay? All right, so I lumped together the last objectives, which are the different types of ways that you can design your experiment. So there's the completely randomized design, which is the one in which each experimental unit is randomly assigned a treatment. So you just grab a bunch of people and randomly pick them. That's it. Sorry about that. I had to switch all the fonts because they were the same. They weren't the same, and it was driving me crazy. Anyway, a matched pairs design is a really big kind of design. It's really key. It's when you match people up based on, like, for example, twins. A lot of times they'll have one twin do one thing, one twin do another, because you can see how it's an effective control, because if they're identical twins, then all the genetics about them are pretty much the same, right? So you can give one a treatment and one not a treatment, that kind of thing. Or a lot of times you'll be paired up with yourself, pre-test, post-test. Pre-test, we give you the SATs, see how you do, and then we give you a whole bunch of studying with us, and then we give you a post-test, we give you the SATs again. Okay. Grouping together similar homogeneous experimental units and then randomizing experimental units within each group is called blocking, right? So if you grab a group of homogeneous people, and that's called a block. So we get a whole bunch of 16-year-old females, then a whole bunch of 16-year-old males, then a whole bunch of 17-year-old females, and a whole bunch of 17-year-old males. And you can also further block them by race and income. Then you can randomly get some from each of those groups and put them all through your little SAT prep thing and see, was your test prep really effective? So randomized block is used when the experimental units are divided into those homogeneous groups, and then in each block the experimental units are randomly assigned to treatments. So some of your 17-year-old females get the class, some of them don't. Some of the 17-year-old males get the class, some of them don't. That kind of thing. All right. That's the end of chapter 1. I hope you enjoyed it, and we will see you back here for chapter 2. See you, bye.